video today. Today we are going to be talking about alkynes, and more specifically we are going to see how alkynes react with halogens. In our previous video we saw how alkanes react with the chlorine. We also saw how alkenes react with the halogens like chlorine and bromine. Now in our video today we are going to look at alkynes, and more specifically we are going to see how ethyne. Now this is ethyne react with chlorine gas is a green gas and bromine, which is a brown gas. Now this is done because we have two carbon atoms, and in between these two carbon atoms it is an earth, and in between these two carbon atoms we have three bonds here, so it is a triple bond. So we said all alkynes must have at least one triple bond. Remember, each bond here is formed, a single covalent bond is usually formed by two electrons, one from each carbon atom. So we have 1, 2, and this is made, we have 3, so 6 electrons are involved in that formation of that triple bond, like that. Now, if now this molecule reacts with the chlorine gas, the chlorine gas this is a symbol for chlorine gas, which is Cl2. Cl2 simply means that we have two chlorine atoms joined together by covalent bond. So we are going to represent it this way for this reaction here. Now, what usually happens when this reaction now is taking place, a single bond here is going to break, and when it breaks, it is going to release 2 electrons. Now it has broken. This triple bond has this bond here has broken, so we are left with 2 bonds here. So we have released this electron and this electron. So these are this electron has been released, and this one there. So after that electron has been released, now chlorine now will also break the bond. That is called bond breaking, and one chlorine atoms comes here, and another chlorine atoms now will be on that will attach to that free electron like that. Now, as you can see, the name of our molecule now will change. It will change. We have now 2 carbon atoms forming this molecule, the longest chain. So it is an earth. And then we have a double bond. So it is not going to be an I now. It is going to be an alkene. So it is going to be an in, like that. So the longest chain, you can say it is a ethyne, like that. But now you realize we have a chlorine atom here and a chlorine atom here. You have a chlorine carbon number 1 and carbon number 2. So that one now becomes automatically a chloro and a chloro. It is in carbon number. This one, you can see it is in carbon number 1 starting from this side here. And the other one is in carbon number 2, like that. So if you combine now this one, the name of our molecule now becomes, we have 2 chlorine atoms in different positions. So we have now the name of our molecule now will become di. We remove this chlorine, we put them here, so it becomes a dichloro, because we have 2. Then in positions number 1 and 2, so it is 1, 2, dichloro, ethyne, like that. So that is the name of our molecule, as you can see it there. Now, if you add more chlorine to this reaction here, you add more chlorine. That means you add more of this. Let us represent it that way. What usually happens now, this bond, one bond now will also break to release 2 electrons. So it will be like that. We have released that electron and that electrons. So this one, the chlorine molecule now, the atoms will break. One atom will come there, join there, and the other one will come and join there. As you can see now, we shall be having 1, 2, 3, and 4. Now we have 4 chlorine atoms attached to that molecule. Now let us try to name this molecule. We have 2 carbon atoms, so it is an S like that. Then, because the carbon atoms are joined together by a single bond, it will be an alkane, so it is an ene. Ethane. So the this longest carbon chain is an ethane. And now we have 4 carbon atoms there, attached there. So 2 are in carbon number 1, this carbon number 1, and another one in carbon number 1. These ones are in carbon number 2. So we are going to put a 2 there. And the other one is in carbon number 10. Now all these, there are 4. So we are going to replace, we are going to say 4, 1, 2, 3, 4 means it's a tetra. Tetra means 4. Now we remove all this. We are just left with 1 chloro here. So the 4 chlorine atoms will be represented by tetra. Chloro means 4. Like that. In carbon number 1, 2 are in carbon number 1 and 2 are in carbon number 2 and 2 like that. So the name of our product that has been formed there now becomes 1,1,2,2 tetrachloroethane, as you have seen. Now let us consider bromine. And this molecule here is a colorless molecule. Remember we started with chlorine, which is a green gas. So when you react chlorine with an alkyne, the end product will be colorless. So that is used as a test for all alkynes. They decolorize chlorine gas. Now, if we start all over again, this time we are going to start with an ethyne molecule like this. This molecule is called ethyne, like that. You react it now with bromine, which is a brown gas. That bromine molecule can also be represented, it simply means 2 bromine atoms joined together by a covalent bond like that. Now, when they react, what usually happens, one bond will break to release 2 electrons like that. And this one will break such that they are going to attach there. So the name of this molecule now will automatically change. We have 2 carbons here, so it is an eth. And because we have a double bond there, it is an ethene, like that. But now we have other atoms joined with a bromo and a bromo here. We call it, when an atom for chlorine, bromine, we are going to say it's a bromo. One is in carbon number 1. The other one is in carbon number 2. So, because there are 2 atoms of bromine in this molecule, we are going to say it's a di. So we are going to replace all these. This is a dibromo. One is in carbon number 1 and the other one is in carbon number 2. Like that. So that is now the name of that molecule. Now if you add more bromine, you react it with more bromine, like that, what usually happens, the same will happen, one bond will break, these 2 electrons, like that. These ones will now break, one attaches there and the other one attaches there. So, in this case we have 4 bromine atoms in this molecule. So we have one there, another there. So one is 2 are in carbon number 1. It is in carbon number 1, carbon number 1. The others are in carbon number 2, carbon number 2, carbon number 2. Now these are 4 bromine, so they are going to be replaced by tetra. So we are going to have all these in carbon number 1, carbon number 2, carbon number 2, like that. Tetra bromo. Because we are 4. Else, because we have 2 carbon atoms in the longest continuously, and all the carbons are joined together by a single bond, so the name of that molecule becomes 1122 tetrabromoethane. Now this molecule is colorless. Remember, bromine is usually brown. So when you start with ethyne and bromine, at the end of the day we have a colorless molecule. So this can also be used as a test for all alkynes, such that all alkynes will be colorized brown bromine gas to colorless. Thank you very much for watching this video. I hope you have understood. We meet in the next video where we discuss a reaction of alkynes with hydrogen halides.